It works?
Yeah.
Good. Okay, so I'm not going to spend a lot of time on this multi-purpose machine with the table saw and shaper aspect of it, in part because I don't really recommend buying one for the table saw, mainly because the saw stop is so much safer. But I will demo it briefly and show some of the things that are unique about it. So in the first part, I'm just showing ripping with the saw, and there's nothing new about that particularly. I have my able-bodied assistant here helping me out,
Yeah.
and there's rails that are adjustable. I'm moving them out of the way so I can rip wood and not have the rails hitting me in the stomach. Well, there's a lot to hit these days. The sliding table is just locked in position while I'm ripping wood. I'm not even going to turn the blade on or get carried away about it. I'm just going to show that, yeah, you just rip wood like usual. Nothing new there. This multi-purpose machine has three horsepower motors built into the base, so it's real easy to change functions from one thing to another. And it is pretty versatile and quite accurate. I'm putting a bar on there that extends the fence. There's also a rail that the fence runs on that's adjustable. Everything's adjustable. So you can cut to the past the middle of a 4x8 sheet ripping, if that's something that's important. And what gets me about this thing is you go way out past the surface of the joiner and onto that rail, and when you lock that thing in, it's still exactly parallel to the blade, and it's been that way for 35 years now. So that's pretty amazing. I'm changing this over now for cross-cutting, and this is where this machine shines if you have large stuff that you want to do. I don't have a panel cutting arrangement like the fast tool that we saw a couple of weeks ago, and so I do all the breakdown of sheets using this tool, and you can actually cross-cut a 4x8 sheet of plywood with it, which is pretty wild. I custom made this little miter gauge so that I could not have the one that came with it sticking out into the shop a couple of feet. The one that came with it must be, I don't know, 3.5 feet long. But this is basically the miter gauge, this whole thing. So you can imagine, if you want to cross-cut something at 22.5 degrees, you can get very precise about it with a fence that sticks out, 2 or 3 feet or 4 feet. I'm locking it in at 90 degrees now, and there's nothing fancy about just simple crosscuts. You just put the wood on and go like usual. But if you want to get kind of excited about it, you can run those rails back towards the operator, and you can see they're fairly long. So when you run them all the way back, 4x8 sheet of plywood is not a big issue, cross-cutting it. Everything is heavy duty, everything's cast iron. When that table is rolling on the rails, it's very smooth, and there might be some slop, I don't know. I'd have to get out a dial indicator to be able to tell, but I've never really had any issues with it. So this is a hold down clamp that goes on a vertical piece, and that's used in several places on the saw to hold all kinds of different things down. So I'm just putting a little chunk of junk wood on there just to show you how it works, because it is kind of interesting to see how you can use that table, that sliding table. It keeps your hands out of the way of the blade. Very simple cam action clamp to hold the plywood in position. The controls are all right there. I just fired it up, and you just take the plywood for a walk through the saw and you're done. Next up is a spindle shaper. It has its own 3 horsepower motor, and for those of you who aren't familiar with a spindle shaper, it's kind of like a router on steroids. This thing is tied down to a 1,000-pound piece of metal, and it's very accurate. So if you put a large cutter on there, and this is not a large cutter, but if you want to raise panels for frame and panel construction, the spindle shaper is a great way to go. I'm doing a really short demo on this, and I'm not going to run it and make sawdust and everything. I just want to show you how it works. But people like Oh, George Knudsen has a spindle shaper with a whole bunch of different kinds of cutters and a power feed attachment. And I know Jim Hickey has used one for years in cabinet making. So we have people that if you're interested in spindle shapers, we could do a much better demo with somebody else than we can with me. I'm just doing this to show you what the machine can do. So you get quite a bit for one machine. Of course, one fairly obvious plus with this is if you have a fairly small shop, you've got the same footprint for your, if you had a separate jointer and a separate planer and a separate table saw, you'd have to have a whole lot of square footage to be able to run all those things. But the same footprint is used for all of these different machines on a multi-purpose machine. And I'll get into prices and availability and that kind of stuff later. Oh yeah, I was going to check time and try to make sure I don't go over a half hour. Okay, it's about 8 now, so I'll quit just before 8:30. Or sooner if I can talk faster. Okay, this is the cutter that came with the machine. It's got inserts that are interchangeable, and there's literally hundreds and hundreds of shapes. You can also buy square ones and get them custom ground to a custom shape if you want to get really carried away. So it can be a lot of fun. Now this is the fence and the guard. I like this setup because it's a big cast iron piece. I don't know if you can see my mouse running around on the screen there, but this is all cast iron, and once in a blue moon you could hit, say, a nail or something like that and end up with carbide flying around the shop at high speed. If that ever happens, I want that cast iron piece between me and the carbide, for sure. There's a 4-inch chute back here for dust collection that works pretty effectively. And there's also a guard here that provides some support for the wood, both pressing down and pressing in against the fence. So that's pretty handy. I just have to remember how to use it now. I don't use this every day, so yeah, so the metal iron piece here pushes the wood against the fence. The wooden piece holds it down, and that works pretty well. This is the joiner-planer combination. And this is the main thing I wanted to discuss. And the big plus with this, the joiner is nothing special. It just joins wood like any other joiner, except that it's 12 inches wide. So if you've got some really large, rough-cut pieces, I've used a lot of wood from a sawmill, and I can handle that big stuff and flatten the face of it, join the edge exactly at 90 degrees, and then resaw large pieces into whatever thickness I want. And I do that all the time in the shop. This is the control for the 3 different motors. So right now it's set for the table saw, and unlike the old shopsmiths, that's it for changing over to a jointer planer motor. You flip the switch and you're done. So that's pretty handy. Now there's a guard over the cutter. One thing I didn't do when I bought this, I don't think it was even available, was I didn't get a segmented cutter head. A friend of mine lives about 10 minutes from us, bought a segmented cutter head for his Robland X-31, and it does a much nicer job of flattening out highly figured wood. You can't tell from this video very well, but that's a piece of western maple with quilted grain. And I realized after I ran it through the planer that I should have grabbed some other chunk of wood to do a demo with, because the straight cutters kind of tear the grain up a bit. But the main advantage of the joiner is just the width. There's nothing else about it that's noteworthy particularly, I don't think. At the end, I'll stop for questions. I'm sure there'll be some.
It's his, is that in his shop?
Yeah, it's his monster saw.
At his shop.
Yeah.
Monster saw. Somebody's got their audio on out there.
Oh,
Okay, so I'll switch over now to the planer. And this is something that I think is pretty slick. It's really handy. Doesn't take very long to switch over. I'm taking off the dust chute now. The same dust hood is used for the joiner as for the planer, but it gets in a new position for the planer. So the whole fence assembly comes off. And Nick, if you're still watching, someday when I'm too old to lift that thing up and get it out of the way, that's when you get this machine. The guard comes off, and that's quick and easy. And then to switch to a planer, this thing is counterbalanced pretty well. Those are heavy tables. They're cast iron monsters, but they move out of the way without a whole lot of effort. And what gets me, I wasn't too sure when I first bought this how it was going to work out long term, but when you put those tables back down, they are not off at all. They're amazingly precise. Okay, so now you run, I've got the dust collector on the back side plugged in either to the table saw or to the planer, either one. And there is one disadvantage here in that you've got to move this table way up to get it near the cutter head. And so that takes a minute, but it's not difficult to do. It's not a huge thing, but it is a minor inconvenience, I guess, compared to separate standalone machines. So I'm going to take a chance with this. I measured the wood, and I'm going to use the gauge, this red gauge that's here on the right, to see what the thickness should be, what the setting should be. Come back. There you go. My assistant sometimes takes off on me. I got to watch him like a hawk. Okay, so we're getting a measurement. I'll check it against that red gauge, which is reasonably accurate. It's pretty close. And I always try to always remember to check which position that switch is in so I'm not firing up the table saw by accident. So there goes the power. Now here again my able assistant wasn't paying attention, so he stuffs the wood in the planer and then remembers to turn on the dust collector. Yeah, it's better to do the sequence the other way with the dust collector on first. But the planer works really well, very quick. I'm checking out the grain, cussing myself, shaking my head, going, oh geez, what have I done now? So I thought I would try turning it around. Maybe I could get less tear out in the other direction. And I did a really light cut for the second cut. However, what I think I did was I just tore the grain up in the opposite direction of what I did the first time. Oh well. So to fix this, I've got a sander back here in a corner, and I just put 36 grit on the drum and spent about 15 minutes sanding a whole lot of wood down. It came out very smooth, but it did end up about a 1/16 of an inch thick. Oh well. Okay, so now I'm going to switch it back to the joiner temporarily and then put the horizontal mortising attachment on. And for me, this is a pretty big deal. This horizontal mortiser is really handy. So I just put everything back, and you can see how long it takes. It's not a big deal. I'll flip the hood out of the way. And the tables go back without any messing around. You just set them down and they're very accurate. That joiner is really precise, really nice. Okay, now one thing I haven't done yet is to build a rack for this horizontal mortising attachment, and that's a mistake because it weighs a lot. It's cast iron, it's very heavy, very precise. Attaching it only requires 2 bolts, and it's tied down tight and ready to go. I did do some editing on the video, and now I realize the error of my ways because we're looking for volunteers to do editing, and here's this edited video. Whoops. So yes, I will help. I will help. I don't mind. Okay, so you put a cutter into the end of this this chuck here and tighten up a clamp onto the cutter, and the cutter is an end mill left turns up spiral cutter. So you can use this actually for doing more than just mortises. You can mill wood with it as well if you have a precise notch you need to machine out or something like that. Putting the guard on is a really good idea because when you fire up the mortiser, you're also firing up the joiner, and you don't want 12 inches of blade spinning around while you're paying attention to your mortising process. You don't want those mistakes that could happen. The 2 handles go on, and that allows the table to move in and out for the depth of cut and side to side for the width of the mortise. Real easy to make adjustments for how wide or how long the mortise is going to be. There's a big wheel down below that also moves it up for elevation, so you can put it in the middle of a piece of wood or wherever you want it, really. And I am going to demo this so that you can see what it looks like when it's running. I'm playing around with the depth of adjustment and the height. Okay. Hurry up there, assistant. And you can get as precise as you want to get. Okay, now here's a closer shot. You can see the cutter coming out, the end mill cutter coming out of the collet. I'm using the same hold down setup that I used over on the table saw. The table has a wood piece that I bolted on, and I glued on a piece of sandpaper so the stock will stay put. And there's a close shot of the handle, at least one of the handles, that controls the depth. And there's a close shot of, whoops, there's a really close shot. There's a large piece underneath that moves it up and down. And this is a close shot of the collet, so you can see how the end mill cutter is installed. Okay. Now, come on, there we go. It's running, and I'm drilling a hole in. Scooting over a little bit, drill another hole. Scoot over a little bit, drill another hole. And then you come back and go across to knock out the webs between the holes and clean out the mortise. Now from this view, you can kind of see what's going on. When I cut to this view, it's a little easier. But I just grabbed the wood and stuck it in place, and then when I started drilling, I realized that I'd put a big knot right in the middle of the mortise. So, oh well, I wouldn't usually do that. I wouldn't usually have that bad of luck, but for a demo, I gotta have some bad luck. Okay, so you just drill the holes and go part way in, go across, in, across. So it's really simple, and of course when you have a whole lot of these to do, it's no big deal. You can do them fairly quickly and they come out really accurate. So there's a couple of mortises. And that is pretty much the end of the demo. Yeah, in fact that is the end of the demo.
So I'm going to talk a little bit about digital design and how it pertains to woodworking. And I'll just get right into it. I'm going to play a little video, and I have a bunch of photos, but the overview is the comparison between the stuff I have designed digitally on the computer and then the finished product, or maybe just a prototype that I produced that I can show you in real life here, or in a photo, and kind of like the capability of design in this way, and the savings in time and efficiency and accuracy. So I'm going to spend a little bit of time on 3D printing, but mostly it's in regards to CNC. But the message I want to get across is the power of designing on a computer and the versatility. So let me get into screen share here. So this is my CNC machine. Okay, so we're all muted there, so I'm just gonna voice over. So this is a quick clip of, I'm basically just flattening these fence boards that had a lot of paint on them. And I repurposed these. I took these off a job site and I turned these into my sauna in my basement. And this 4-foot by 8-foot machine allows me to surface anything that size or smaller, of course. It's very, very flat, very, very accurate. This is it's called the Y-axis, and it's 8 feet, a little over 8 feet. So you can flatten a big slab, or you can flatten a bunch of smaller pieces. later on towards the end of the presentation, I'll show you some of the details of the machine, but it has sensors way on this end and way over here. And the machine reads those, it reads the distance from this part over here to the end of the machine. And so it automatically squares itself every time I turn it on and I go through the sequence. And so I can cut perfect rectangles, perfect circles, doesn't matter what the shape is, it's dead on. And I'll do a demo where I do kind of an inlay, and I cut some material out, and then I have another piece that we're going to fit in, and you can see the fit is just dead on. So we'll start, get into some photos here. So I guess I want to spend just a minute to go over what it is to design digitally. This program here is the one I use primarily. This is CAD, and this particular program also has CAM. CAD stands for computer assisted design. And this manufacture button over here, that is a CAM, which is computer aided manufacturing. And so I can switch between the design workspace and the manufacturing workspace. And the way, you can just design whatever you want in CAD once you know how. And then this CAM is a little more specific to the exact way you're going to make the thing you've just designed. This can do laser cutting, it can do drilling, it can do 3D printing, it can do plasma, it can do a wide variety of tasks. This is actually not something I designed myself, but this is a stool seat for a woodworker. He used to be down in Seattle, and now he's up here in Bellingham. And so he brought this file to me and said, "Can you make these seats?" And I said, "Maybe." These blue lines and the yellow lines are what are referred to as tool pads. So now this image here is what you get out of the design. And this design came from somebody else. They just handed me this file. This is the CAM, which I came up with. And so my CAM is going to allow me to tell my machine exactly how to cut this. This, I don't know if you can see it over here, but it says T51. That is calling out a specific tool. In this case, it's a 1/2 inch ball nose spiral cutter. And it's about 5 inches long because I got to get deep just for some applications. And then this T3 is a 1/4 inch ball end. Actually, they're end mills. So they're both ball ends. And so they're going to take these different paths. You see, I have these two, the pocket and the finish are highlighted in blue. And so that's what we see here in the simulation. And this isn't live, this is just a photo. But if I wanted to, I could click this simulate button and it would pop up the tool. It would literally show the router bit in the correct size, and it would follow all these blue lines, and you would see how it was machined. And here, it's called a contour, where I'm going to cut out this profile. And so now only that is highlighted, only this tool path. You can see there's a series of lines. And so the tool that you can see right here is going to step down. And I think I'm probably only removing about a 1/16 of an inch in depth per pass. So it's actually, it's kind of helical. It's just a big spiral, and gradually it goes down and down. And these are the finished pieces. There's 3 of these in cherry. We did a couple of test cuts in poplar. So there's those 3, and I have a few more close-ups. This is the result of the 1/4 inch ball end going back and forth in this way. And I hand these off, and you can see this bit of material that's remaining. I leave that there so that the vacuum system on the CNC table doesn't lose any air pressure while it's cutting. And then I hand these off to the woodworker, and he takes his bandsaw and he cuts this tiny thin thing out, and then a flush router, and then he sands all this into smooth. It saves him a lot of time per seat. It takes me, I think, 40 or 45 minutes to cut each one of these, but it would take him 6 hours for each one. Some more close-ups of the seats. This was one of my first projects. A company, a mining company, came to me, and they had just purchased a foundry, and they need this component in the mining side of their company, and this is a rock crusher. This has a mating component which is more curved, which I'll show you later. But the two like crush together, and what results is a particular, pebble size that comes out, and they're extracting gold in this case. So they came to me and they wanted me to create this in wood so that they could build a negative and then pour steel to create this component. What they learned afterwards, because they are a mining company, they're not really, they don't really know very much about pouring metal, but there's a huge shrinkage factor. I think it was 13%. So when they made this piece, it ended up 13% smaller than the model. And they didn't account for that, and neither did I, because neither of us knew. Here's a top view of that same jaw. And then this is, I just glued up some fur. I bought a post at Home Depot and then glued this blank up. And that is the, I think that's called the fixed jaw. So that's it's more straight. And then this one has that curve to it. And so it, actually never saw it in action, but it makes tiny rocks. And I put this this good stuff finish so that when they pack this into a mold with sand, and so I used a finish so that the sand would not stick to it. Again, Fusion 360, this is my CAD CAM program. This is one of the components from the light fixture that I made, that I brought to the club. I think some of you have seen it. That's a light fixture, but drawing in that program allows me to calculate these sections here. Each one of these bands is actually a cone. So when the veneer is laid flat, I cut a curve, and then when you bend it, it ends up horizontally. And this would be tough math. A lot of paper and graphite would be wasted in these calculations. But it's trivial in the program, and I know exactly how to cut everything. One of these middle ones is a 52-inch radius or 54-inch radius. And so doing the math and making these templates by hand would be challenging. This is, I think, there's maybe 2 3D printed things in this presentation. This is the magnetic dust port that I brought to the club also. So in this model, 1/2-inch magnets go into these slots. These slots are 1/100th of an inch smaller than the magnet. So you pound the magnet in, and then it's held in just by tension. Another view. And then here are the 3D printed components. See the magnets in there. They use just cheap black plastic. In total, each one of these, I think, cost me $5 or $6, and it's almost all the cost is in the magnets. Each one of the plastic components is probably less than $1, and it takes about 5 hours to print one of these. but I made these because I found something a lot like this online, but it was going to take me 6 weeks to get. So I just designed my own and stole his design. This is something I use all the time with my CNC machine. It's just this piece here holds a keypad that I use to control the CNC machine. And this is a magnetized dust port, and I basically just glued the two together in the design environment and printed that off. And so you can see it here, the keypad set in there. And then that component gets sandwiched between these two dust port components, so I can remove this really easily. I'll remove this section of the hose to vacuum off the table when I'm done, and sometimes I'll knock this free. So I like to just pull this off and put it on the side. Okay, so one of the other benefits of CNC drawing, can I get rid of that? There we go. This is for a kitchen that I just finished in Seattle, and I designed all these cabinet fronts, and most of them were cut on the CNC machine. They're just plywood, edge banded. But you can see all my dimensions here. They're very, very accurate. They're more accurate than you would need to be. And this is the result. You see here, I was kind of switch back and forth here. You can see that this is the refrigerator panel, and then above the refrigerator. And what I really like about drawing in CNC is that once I was on the job site with all of these components, I felt like I had already built the kitchen because I'd gone through all the steps in my head. So all I was doing was kind of the mechanical motions of screwing things together and leveling things, but everything already had a place. I already knew it front and back. So this is a model of this is a prototype for a table base, and this component is 1/4-inch steel. It's going to be bent on a very specific radius, and it's going to have this circle cut out of it and have these flanges welded. And I 3D printed the bases just to kind of get a sense of scale, and then I CNC'd this kind of groove in here to get a sense of what the inlay would look like. And another benefit with the CAD drawing is I have these drawings that are just ready to go out to the steel manufacturer. I have all of these really specific, you know, this edge, that's an 82-inch radius. This inside edge is a 78-inch radius. And you could add all these notes. And these types of drawings, these guys are used to seeing. So I can communicate with them effectively to get the end result. And I haven't built this yet, but I'll be sure to show you when I do. This is a model of a tiny house I designed that I haven't built yet, but I hope to build something similar one day. And I've built a model out of this as well. I do not own the technology to do this, but I have friends that have laser cutters, and that's how this was produced. And I just, you know, super glued all this together as a prototype. And again, being able to make those professional architectural drawings allows me to communicate with the people who are, you know, manufacturing these components in the long run. These are some clamp pads that I made for Tom DeLezy. He sells those aluminum clamps, which are priced really well, and they work really well. But I thought we should have a way to make them non-marring. And actually, these are not Tom's pads. These are for the Rockler clamps that I own. We'll go back and forth here. So this is the finished product. You can see it removed from the clamp here. In this image, you'll see 4 of them together, joined at 90-degree angles. And I've overlapped them just a little bit. And that helps in the 3D printing process to stabilize them, because the ones that are on this axis support the ones that are on this axis and vice versa. Otherwise, it can get a little unstable, sometimes fall over or slough off. And so combining them in that way allows me to get a reliable product. I've made a lot of those for myself and a lot of them for Tom. This is an image that one of my clients pulled off of the internet. It's a heron. And my client she's a designer, and her client wanted this printed, engraved onto 4x8 sheets of this Baltic birch, and it's dyed blue, and you can see the relief cuts here. So the part that we've carved out is the birch underneath. This is what's called a plenum, and this is 8 foot long here. It's actually 97 inches by 49 inches, and this represents a sheet of MDF. I'll get a little closer here, but what this is an air box, essentially, that's used for my vacuum table. So I don't have to screw anything down on the CNC machine. I have a very powerful vacuum, and I can operate one of these quadrants at a time, or all 4 of them, or some combination, so that if I have a small piece, I only turn on the one quadrant, etc. And it's just a grid. These squares are, I think they're 1 inch, or maybe they're 2 inches. And then there's a channel that's cut a little deeper, and you can kind of see the 3D geometry there, where these squares are raised, and then all these channels are recessed, and that allows air to flow. You don't see it in this model, but in the center of each of these quadrants, I have a 2-inch hole drilled, and I have PVC plumbing piped from the vacuum to this plenum, each quadrant. And so the air comes up through here, and then on top of this, I have glued lightweight MDF, and the vacuum is powerful enough to draw air through that MDF sheet material, which I really like to demo sometime. It's pretty cool. So this is my top layer of MDF here, and below that is this grid plenum that I've just shown you. So this that I'm going to show you here is the sequencing that I do every time I turn the machine on. It's all automated. It's finding sensors, and this little green box is a sensor itself. It's inductive, and so what it's doing is looking for a piece of metal. And when it finds that piece of metal, it learns its physical limitations, and it sets the 0 coordinate. And there's my little keypad that I made the holder for. And this is called a touch plate. And so I'm creating an electrical circuit between the bit and the touch plate. And when this bit touches the very top of this touch plate, the computer knows that the bit is exactly 1.5 inches above the table. So not only does it know where the corner is, it knows where the bottom corner is. And this allows me to cut all the way through the material without damaging this MDF, which is called the spoil board. Now, I always intentionally cut into the spoil board to guarantee that I get all the way through. And I go down about 1/100th of an inch, and it's very, very accurate. It doesn't matter where you are on the table. It's very flat. And as I damage, and it happens, as I damage the surface, I just put a bigger bit on there. I use a 1 1/4 inch bit, and I run a special program that flattens the entire table. Takes about 20 minutes and is dead flat, totally smooth when I'm done. All right, so this video is really the meat of it. I'm going to cut a pattern that I've designed, and on one side is, we'll just run it here. I have cutouts on one side and then the plugs on the other, so they're slightly different sizes. So I've got my workpiece positioned in the 0, 0 position on this one quadrant, and I've just turned on the vacuum, and you can see I'll try really hard to move this, but the vacuum's holding it down very tight. So the machine knows exactly where it is relative to the table. And I have this 1/4 inch MDF, and it's very loud, so that's why I have it muted. I have 2 vacuums running, plus the dust collector, plus the spindle. So it's headphones all the time in my shop. I have these giant bow ties I'm cutting, as well as a couple squares and a circle, and I'll show you the process of fitting them in. So this plug here is going to fit into this hole. So this scrap in the middle ends up being smaller than this one by the diameter of the bit I'm using. And I actually had to, this one is the second iteration. I had to run this twice. I've used this bit enough that it's a little dull, and it's actually a little bit smaller in diameter than the computer thinks it is. So I had to go back and reprogram it, tell the computer that the bit was a different dimension to get it to cut accurately enough. You'll see this, the machine is cutting each shape twice. And the reason for that is that on the first pass, it's not cutting all the way through. And that is so that I don't lose vacuum in this channel here. I don't want a bunch of air escaping, because what can happen is one of these little pieces could get loose if there's not enough vacuum pressure. So I wait till there's just a really small, it's 1/10 of 1 inch material left at the bottom of this sheet. And so that's what's happening now, is the machine is removing that final 1/10 of an inch. The bigger the piece, the less likely it is that we'll lose it. But since the purpose of this video is to demonstrate accuracy of the machine, I didn't want any shifting. So now it's done cutting. And go turn off the vacuum, and then I'll actually be able to move the pieces around. And we'll just, I'll fast forward on to the next video, and we'll actually fit the pieces. So you might notice there are 2 sets of squares. This set of squares is programmed very slightly differently than the rest of these. Each of these 3 plugs is 8/1000ths of an inch smaller than the hole it's designed to fit into. This square is exactly the same size as this square here. If you cut them exactly the same, they don't fit. And you'll see that as we fit them. This one really does not want to fit. and these all fit really nicely. I don't know what I'm saying there. We'll just fast forward a little bit here. So I'm basically deburring. I'm just taking off the bottom. I got some 220 sandpaper. I just want to make sure that when I try to fit these in, there aren't little fibers getting in the way, because they're very, very close fits. Now this one, like I said, won't matter. I'd really have to take a lot of material off to get this one to fit, because it's the exact same size as this hole. There's a much bigger bow tie, than you'd typically use, but I bought a 2x4 and I figured I'd use it all. It's a really light chamfer, 220. I'm not changing the shape at all, and I'm only hitting the bottom edge that's going to go in first, so the top edge remains crisp. You can see as I set this flush, the bow tie disappears entirely. You just can't see it. The lines are that good. The square here you can see a little bit, but I ended up putting it upside down, so the MDF on the other side was a little bit lighter in color, but there's still no lines to speak of. So that's the capability of CNC. It's that accurate, and if I decide that I want it a little bit smaller, it's no problem. I just go back into the program and change it a little bit. So I'll stop my screen share.